We've got a question here from a recent IB exam, May 2015, and it's a curve here with f-x. That's very important. This is f-x, and most of the question is going to be asked about f. So here's f-x. It touches the x-axis at A. It's got a maximum point at B. It goes through the x-axis at 0. It goes through again at D, and it's got a minimum at C. The first question, it says, find all possible values of x where the graph of f is decreasing. Now, if we just look at this, this is the gradient of f. This whole function is the gradient of f. So here, I know the gradient of f dash is going down, but the gradient of f is positive because it's above the axis. So it's good here. It's increasing, it's increasing, it's increasing, it's increasing. But here, where f-x is below the x-axis, f is decreasing because this indicates a negative gradient for the function that's being differentiated. So for this one, I'm going to say it's from 0 up to D, but not D itself. Okay, find the value of x where the graph f has a local minimum. So a local minimum or maximum or possibly a point of inflection will occur where it cuts across the x-axis. So there could be one there, there could be one there, and there could be one there. Just not looking for C. C is not the minimum of f. C is the minimum of f-x. So one of these points. And local minimum, I'm going to plumb for D. And it says justify your answer. And here's why. At A, f is increasing, increasing, increasing. It gets to A and then starts increasing again. So at A, my f is going up, going up, going up. It gets to A and then it starts increasing again. So actually at A, that looks like it's a point of inflection. At O, the gradient is positive before it gets there. So it's increasing before it gets to O, and it gets to O, and then it starts decreasing. And at D, it's underneath the axis here, so it's negative gradient, but above it, it becomes a positive gradient. So it's going down, negative, 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 and then positive. So we've got a point of inflection, a maximum, and a minimum. So this is how I would justify it. I would have this and say that at D we've got a negative gradient, and then at D it turns into a positive gradient for F. Okay, and finally, it says the total area enclosed by the graph of f-x and the x-axis is 15. Now the area enclosed is here and here. So I want to integrate f-x. When I integrate f-x, I'm going to get fx. So I'm going to go to the next page to give myself a bit of space. So what I want to do is to integrate f-x dx. Let's just go back. I want to get this first area. So the upper limit is 0 and the lower limit is a. So 0 to a. And then I want to add on, I'm going to leave this as a minus for the minute. I'll show you why. Because I'm going to add on this area. But this area is a negative because it's below the axis. So what I'm going to do, instead of adding these two areas, I'm going to do this one, take away this one. And that negative will negate the negative area that comes out. So this is d and 0 for the limits. And this is f-x I'm trying to find, dx. And it tells me in the question that's 15. So if I go through this, it's going to give me fx with the limits o and a, take away fx. Remember, this is worth 8 marks. It's worth doing a lot of working out for this. And the limits are d and 0 equals 15. So now I put in f0, take away f FA, take away FD, and then take away, but I've got a minus outside, so I'm going to add on F0. And all of that gives me 15. Now, FA is given in the question. By the way, I've got two F0s. Let's start with that, two F0s. FA is given in the question as 3, so I'm going to replace that with 3. And FD is given as minus 1, so I'm going to replace this minus with a minus 1, so it becomes plus 1, and that equals 15. So I've got two F0s equals minus 2 equals 15, so that's going to give me 17, 2F2, 2 FOs, and FO will give me 8.5 or 17 over 2. So that's quite a lengthy question. It's the last question on there, and that's the last bit worth 8 marks.